Good afternoon, my YouTube viewers. It is Crystal here. I'm just here this afternoon because I wanted to do a code review for you on a Kaggle community competition. The community competition is Drug Design Challenge, and it's for cancer drugs. And I've used TensorFlow to do this, and basically, the competition is already over, but you're still allowed to enter competitions or after they've entered, but you just won't get on the leaderboard, which is what happened to me. So I entered the competition and I did a late submission and I just didn't get on the leaderboard. But the problem is with these community competitions, quite often people don't show their code, and because people don't show their code, you have no way of knowing how you can improve your score. And so I did the competition to the best of my ability, but since there's not any other code for me to look at, I don't know how I could improve my score, but I did it. This is a linear regression problem, and I wrote the program in Kaggle's Jupyter notebook, which is stored in my account. And what I will do, I will leave a link to the Jupyter notebook in the description box down below. So and you can see that my best score was 65787. That was my best score. And since I didn't get any help, and I never get any help, if people make their Jupyter notebooks public, then you can look at the Jupyter notebooks and you can see what they did, and you can try to incorporate some of their ideas into your ideas to try to improve your score. But they haven't made their Jupyter notebooks public, so I can't do that. So I did my best, and we'll review the score. We'll review the code. This is a regression problem to develop cancer drugs. So after we have created the Jupyter notebook, then what we want to do is we want to import the libraries that we're going to need to run the program. And so we're going to import NumPy as NP, and that creates NumPy arrays and performs numerical computations. We're going to import pandas as PD, which creates data frames and processes the data. We're going to import OS, which is going to go into the operating system and retrieve the files that we need to execute the program. We're going to import sklearn, which provides machine learning functionality. We're going to import TensorFlow, which provides deep learning functionality. We're going to import matplotlib.pyplot as PLT, which helps to visualize the data. And we're going to import Seaborn as SNS, which visualizes the data statistically. So after we've imported our files, then we're going to use the OS library to retrieve the files. And we've got 3 files to retrieve, being train, test, and submission. After we have retrieved the files, we're going to use pandas to read the CSV files. And we're going to give them names, so we're going to call them train, test, and submission. And then, after we've read the files, we want to view the files. So, since there's so many columns of data, we set up pd.set option display.max columns none, and then train. And you can see there's 5,215 rows by 1,421 columns. So that's the largest data set I've ever worked on. Check for any null values. Fortunately, we don't have any null values, so I don't have anything to deal with in that regard. then we check for test. One thing that I will say about the training file is you have the regression target, that's your regression, and then you have a classification target. So if you wanted to, you could make this a regression, which that's the competition question, what they wanted you to do, but you could also make it a classification as well. So, but we made it a regression because that is what the competition question said to do. If we check our test file, we had 1738 rows by 1420 columns. So the only one that you don't have is the regression target. We check for any null values. We don't have any null values. And then we check the submission. In the submission, they want to see the ID and the regression target. So now we're going to analyze the target. And when we analyze the target, we create a histogram of it. And you can see that it looks pretty similar to a normal distribution. We do a value counts of the target, and you see you've got a lot of ones. And so basically, because you've got so many ones, you're not going to be able to use sklearn to split the data set into training and validation sets. So we had to use pandas to do that instead. I decided to drop the classification target because it was a binary, so I just made the decision to drop it. And so they even in the test set, they misspelled the word target. So if I had wanted to use classification target, I would have had to have renamed it. But I just made the decision to drop it. And I don't know if my score would have been better if I had kept it in place. Then I use SciPy, that's another library that we've imported that I forgot to name at the very beginning, to use the Kolmogorov-Smirnov 2-sample test to check to see if the columns of data are from the same distribution. And when we did that, we found there were quite a few columns of data that are not from the same distribution. So I put those in a list called to drop, and then on the train and the test set, I dropped those columns of data because they would have a negative impact on the accuracy since they're not from the same distribution. Okay. Then I decided, because there were so many columns of data to go through, I decided to use only the numeric columns. So I've got the num train is a selection of only the numeric columns, and num test is a selection of only the numeric columns in test. And so you can see that we went from 1420 columns of data to 1407. So if I had wanted to, I could put a shape down here, and that would give us more insight into exactly how many columns of data were dropped. And I could do that just to do the shapes. But you can see the shape here, 52, 15, 1407, and 1738, 1407. I didn't do a heat map because I thought that there's so many columns that it's going to affect the heat map. So I decided to remove the columns that have a high correlation. And you can see of all of those columns, 2 of the columns actually had a high correlation. So I removed those. So now we define our x and y. Y is your target, x is your num train, x test is your num test. And then I use sklearn standard scaler to scale the columns, because that's what's wanted. That's what's wanted, is to scale the columns. And so we scaled the x, and then we scaled the x test as well. So that's what we did. And then now you can see x, and you can see that all of the values are scaled. And then now what I had to do was I had to split the data set, but you couldn't use sklearn's train test split to do that because you had two values that were only 1. So what I had to do was I had to use pandas to do that. So df equals x, dfy equals y, df train equals df.sample, frac equals 0.9, random state equals 42, df val equals df dot drop, df train dot index. Y train equals df train pop y, y val equals df val pop y, x train equals df train, and x val equals df val. And you can see that we check the shape as well. So we've got the shape of all of these x train, x val, y train, y val, and x test. And then so now we're going to get into the deep learning part of the program. So we're going to import the TensorFlow library and associated modules. We're using TensorFlow 2.12. Now we're going to define the model. We're going to have a sequential model, and we're going to call it cancer drugs. And I wasn't sure how many neurons to use, so I used 1500 neurons. And I used ReLU activation, except for the output where we had a linear activation. So, and then I compiled it using mean squared error. Optimizer was RMS prop, and metrics is MSE, so that's another mean squared error. And then we set it up for early stopping and model checkpoint. We trained the model to 100 epochs with a batch size of 32 and callbacks as early stopping MC. And then we evaluated the model. Val loss, val act equals model evaluate x val y val. So we trained the model. Set it up for early stopping and an MSC of 0.73. Now what we do is we set it up on a grid so you can see your loss and your MSC. So you can see that on the training set and the validation set, which are very close. We're going to predict on the y variable, called x val, call it y pred. So we predicted on y pred. And now we're going to set up and check the root mean squared error. You can see we've got a root mean squared error of 0.85. We put the actual values against the predicted values, and you can see where the actual values fit on the predicted values. And then we have a data frame where you can check the actual values against the predicted values. And now we predict on the test set, and we get our predictions. I created a histogram so you could see what the predictions look like, and that looked pretty similar to normal distribution as well. And then we set up the submission, and the submission file, and that is what we submitted to Kaggle. And when we submitted it to Kaggle, I got a public score of 65,955, and if you check the leaderboard, there were other scores that were higher than mine on the leaderboard, but because they didn't make their code available, I can't tell you what they did to get a higher score. So I did my best. If you've got any ideas about what I can do to improve my score, then please certainly let me know, and I will incorporate those ideas into my code. So I'm going to go ahead and conclude this code review. If you've got any ways I can get a better score, then certainly by all means let me know, and I'll do my best to incorporate your ideas into my work. Now there's something that I might do. I might take out the standardization and see if the accuracy is improved with no standardization. That's something that I might do. So thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you again for watching my video. I look forward to making more code reviews for you in the future.